Example, consider the function f of x equals x squared minus 2x plus 4. Find the following. First we want to find f of 3. So remember that this notation, f of 3, means that 3 is the input. So 3 is going to go in everywhere we see an x in the original equation, because we're replacing x with the 3. So on the right side of the equation we do the same thing. Instead of just x squared, we're now going to have that number 3 being squared, because that's what the function's telling us to do. The function's also saying whatever your input is, we're going to do minus 2 times the input. So minus 2 times our input, which is 3. And then we have a plus 4 on the end, so we keep that plus 4. So now this just turns into an order of operations problem. We do our exponents. So 3 squared is 9. 2 times 3 is 6. So we end up with 7. And that's our answer. So when we plug 3 in for x in our equation, we'll come up with a y value of 7. So if you think back to on the first page when we were talking about graphing equations by plotting points, this is just another way that you can denote the point that you came up with. F of 3 equals 7 means that the point 3, 7 is on the graph. All right, let's go on to part B. So now we have an input of -1. So that means everywhere we see an x in our equation, we'll put -1 in its place. So instead of just x being squared, our x is now a -1. So we take the -1 and we want to square all of it. So it's important that the -1 is in parentheses to denote that you're squaring that entire number. Minus 2 times -1. And then we have just plus 4 on the end. So when we simplify, -1 squared is a +1. -2 times +1 is a +2 plus 4. And it looks like again we come up with a 7. Okay, for part C, even though we have something that looks a little bit more complex in the parentheses, you're still going to approach it the same way. Part C is telling me that everywhere I see an x in my equation, I'm going to put a +1 in its place. So instead of x squared, I'm going to have a +1 squared. Then we have -2 times, instead of x, we're multiplying by a +1. And then we have a +4 on the end. There's no x with it, so we just keep the +4. All right, so we've done the evaluating the function part. Now we just need to apply our rules to simplify this. So if we look at the a +1 quantity squared, make sure that you don't say that that's equal to a squared plus 1. Remember that when you square something, it means you're multiplying it by itself. So that means we have a +1 times a +1. So you can use the FOIL method. First times first is a squared. Outer times outer is 1a, or just a. Inner times inner is another a. Last times last is 1. So this will simplify to be a squared plus 2a plus 1. So we can go ahead and plug that in. A squared plus 2a plus 1. Now with our next term, we just need to make sure that we distribute that -2. -2 times a is -2a. -2 times 1 is -2, and we still have that +4 on the end. So now I see that my 2 a's cancel out, and we're left with a squared we have 1 minus 2 is a negative 1, plus 4 is 3. So this simplifies to be a squared plus 3. The last topic we want to look at is finding the domain and range of functions. The domain of a function is the set of all x values that do not make a function undefined. Below is how we can find the domain of various types of functions. So let's start off with polynomial functions. So remember, polynomials mean that you have x raised to a natural number exponent, right? So you may have x cubed plus 5x plus 9, anything like that. Well, for a polynomial function, the domain is all real numbers. You can plug any number in for your x when you're dealing with a polynomial. Now, if we look at rational functions, and a rational function is when you have a polynomial divided by another polynomial. The domain of a rational function is all numbers that do not make the denominator equal 0. Because we know if we get 0 in the denominator, that means it's undefined. Okay, so all numbers that do not make the denominator 0. Okay, for a square root function, well, with square roots, you can only take the square root of positive numbers. So the domain of a square root function is all numbers that make the radicand, the part under the radical, positive. And this will make a lot more sense when we go through the next example. Now the range we're not going to focus on so much. The range you can determine, the range represents all of the y values that a function takes on. And usually you'll determine the range by looking at a picture. But the domain is typically the focus of what you're going to be asked to find. So in this example, find the domain of the following functions. Write your answer in interval notation. So in part A, we have a polynomial. We don't have any fractional exponents. We don't have any variables in the denominator. Okay, so since this is a polynomial, that means I can plug in any number I can think of for x, and I'll get an answer out. So the domain is the set of all real numbers. So often that's just denoted with an R with a double bar. But if you put all real numbers, that's fine too. Okay, for part B, we're dealing with a rational function. So a rational function's domain is any real number except the ones that make the denominator 0, because you cannot divide by 0. So to figure out the domain, we want to see, well, what number does make the denominator equal 0? And we know that that's the number that cannot be in the domain. So I'm just going to write 5x minus 10. We don't want it equal to 0. So if we solve this, we have 5x is not going to equal 10. And we come up with x cannot equal 2 after we divide both sides by 5. So the way that we write this in interval notation, that means we can have any number less than 2. So that would be negative infinity with a parenthesis, comma, 2. Since 2 is not included, we use a parenthesis with it. Then we're going to put a union sign because we can also have all numbers bigger than 2. So we have another parenthesis, 2, comma, and since there's no bound, positive infinity with a parenthesis, since nothing ever equals infinity. So that U is just a union symbol. So it means that these two sets combined are our answer. Okay, lastly for part C, to find the domain of a square root function, whatever is under the radical, the 6 minus 2x, must be positive. And it's actually okay to take the square root of 0. So it needs to be greater than or equal to 0. So let me modify my rule up there. The domain is all numbers that make the radicand, the part under the radical, positive or 0. Okay, so that's why we have the greater than or equal to. So now we have a linear inequality to solve, which we saw earlier last week. So we're going to subtract 6 from both sides, and that will not change the direction of our inequality. So negative 2x is greater than or equal to negative 6. So now we need to divide both sides by negative 2. Division by a negative will change the direction of our inequality. So we'll end up with x is less than or equal to a positive 3. Okay, so how do we put this in interval notation? If x is less than 3, that means we're looking at everything to the left of 3. It can also equal 3, so that would be with a bracket. So our smallest number in the set would be negative infinity, not inclusive, comma, 3. And since 3 is included, you close that in with a bracket. So as long as I pick a number in that interval, I will be able to find the square root of it.